Today, we are going to discuss about the lecture of microphones. Now, we will start from the introduction of the microphones. That is, it is an instrument whereby sound waves are caused to generate or modulate an electronic current, usually for the purpose of transmitting or recording sound, such as a speech or music. So, what is a microphone? Basically, microphone is also called a mic that converts sound into an electrical signals. Microphones basically are used in many applications such as telephones, hearing aids, public address system, for concert halls, public events, motion picture production, live and recorded audio engineering, sound recording, two-way radios, megaphones, radio and television broadcasting. So they are also used in computers for recording voice, speech recognition, non-acoustic purposes such as ultrasonic sensor or knock sensor. Microphone also is an internal transducer that converts sound into the electrical signals. You can see the diagram here. In this diagram, this is a diaphragm, that space for the sound waves, and this is the audio signals. So what is frequency response? Frequency response basically is a quantitative measure of the output spectrum of a system or device in response to a stimulus and is used to characterize the dynamic of the system. It is a measure of magnitude and phase of the output as a function of frequency in comparison to their input. You can see the diagram also here. For the linear system, doubling the amplitude of the input will double the amplitude of the output, and summing two inputs produces an output that is sum of the two corresponding outputs of the individual inputs. So two applications of the frequency response analysis are related but have different objectives, because some frequencies are exaggerated and others are attenuated. That means reduced. This is interpreted as meaning a nearly flat, linear plot between the stated frequencies with variations in amplitude of one more than plus or minus 3 dB. Frequency response is the steady state response of a system to a nearly input. In frequency response method, we vary the frequency of the input signal over a certain range and study the resulting response. Because for a good frequency response, headphones and microphones is considered a very good. Amplifiers, CD, DVD player, and other strictly electronic devices should be within 1 dB at their most. So which frequency response curve in the ideal? Basically, we have the value means that frequency is attenuated frequency can do anything with the help of their signals, because the frequency response curve is pretty flat with no serious peak, dips, or other ups and downs variations. Ideally, whether a microphone has a flat or shaped frequency response, a frequency response curve should be a fairly smooth line. It is equally sensitive to all frequencies. In this case, no frequencies would be exaggerated or reduces, because some of the higher values means that frequency will be exaggerated. If it has a lot of abrupt peak and valley, the microphones probably was not sound very natural, and it may have a greater tendency to cause feedback with a plain system. Next, we have a microphone polar patterns. Basically, polar patterns refer to the sensitivity of any given microphones to sounds arriving from different angles to its central axis. As we can see, the shape of the polar pattern touches the outmost circle of 0°, falling below the 5 dB at the 90 and 270 decibel points. It is essential to know the polar patterns to get the perfect recording out of your microphones. Here you will learn everything you need to call yourself a pro. A polar pattern defines how much of the signal will be picked up by the microphone from different directions. Polar patterns are also sometimes called the pickup patterns. By selecting the right pattern, you can avoid unwanted sound sources to bleed into your signals. Adjust the mix between dry and room sound, or change the frequency response and influence the proximity effect, because some microphones pick up sound equally from all directions. Because polar pattern indicates how sensitive is it to sounds arriving at different angles about its central axis. Now we have omnidirectional. Omnidirectional microphones is that kind of microphones that picks the sound from all the directions. An omnidirectional microphone is designed to pick up sound from all sides of the mic, meaning that a speaker can talk into their microphones from any direction and it will be able to capture the sound. The only real negative side effect to using an omnidirectional microphone is their potential to pick up unwanted sound. It is a very disadvantage. If you are looking to pick up something very specific and drown out the surrounding noise, an omnidirectional mic is not the device that you are looking for. So in a multi-microphone setup, omnidirectional microphones may not be an ideal choice. However, an omnidirectional mic would often provide a better performance because of its less vibration, handling, popping, and wind noise and no bass build up. In some cases, situations where the mic position must remain fixed while the sound sources is moving. Next, we have a cardioid. Cardioid microphone is picked up mostly from their front, but to a lesser extent, the sides as well. You can see the diagram here. Cardioid mic captures everything in front and block everything else. This front focus pattern will let you point the mic to a sound source and isolate it from unwanted ambient sound, making it ideal for live performance and other situations where noise reduction and feedback suppressions are needed. If you are chosen a specific room to record it in because of its reverb or ambience, an omnidirectional mic will probably be a solid choice. While if you are performing on a loud stage or in a booth, you will likely favor a cardioid mic also, because it is the best whilst leaving some latitude for mic movements and ambient noise. Example, handheld mics. Now we have a hypercardioid microphone. Hypercardioid microphone basically has a very directional hypercardioid polar pickup pattern. It is most sensitive to on-axis sound where the mic points, with null points at 110 and 250 and a rare loops of the sensitivity. Hypercardioid mics are polar in film due to their high directionality. It also direction where there is a lot of ambient noise, picking up sound from a subject as a distance. In this in-depth thing, we all discuss the hypercardioid microphone follow pattern in great deal in order to answer any questions you may have about hypercardioid microphones. Now we have a supercardioid microphone. Supercardioid microphone basically a hypercardioid, except there is no more front pickup and less rear picked up. A supercardioid microphone basically has a very cardioid and directional supercardioid polar pickup pattern. It is most sensitive to on-axis sound and null point at 127 and 233 and a rare lobe of the sensitivity. Because supercardioid mic are popular in film due to their high directional also as a hypercardioid microphones. We will discuss here more difference between the hypercardioid microphone and supercardioid microphone. So a supercardioid polar pattern is more directional than cardioid. Hypercardioid even more so. Unlike cardioid, both of these polar patterns have sensitive rear loops that pick up sound, which can make positioning these hyperdirectional mics somewhat tricky. In this, we can discuss that it is possible by adjusting their mixed common definitions, state that a hypercardioid is produced by combining them at a 3:1, while supercardiate is produced with a 5:3. Now we have a bidirectional microphone. Bidirectional microphone, basically a type of microphone, is based on the pressure gradient principle. The sound can reach both sides of the membrane. The microphone provides a signal whenever the sound is different on the front and the back side of the diaphragm. Bidirectional microphones are used in applications where sound is recorded from the front of the microphone and back of the microphone. You can see example and watching the diagram, but not the sides. An example of this is a lecture or presentation where a professor gives a lecture to an audience and accepts questions from them. Basically, bidirectional microphone is a very great microphone. In this, it can pick up the sound from front and the back. We have a shotgun microphone. Shotgun microphone basically less sensitive to their side and rare than other directional microphones. It is common uses of shotgun microphones are for talks or speeches in meetings, conferences, and lectures. In scenarios such as these, the speaker don't need to hold a microphone and speak into it, or wire a microphone on his body in order to record his speech or a lecture. Basically, the most expensive shotgun mic can only capture audio from a distance of 6 to 10 feet, while more adorable mics sound their best at a distance of 3 to 4 feet away. Interviews are typically shot from about 7 to 10 feet away from their subject. One of the most misunderstood types of the microphone is the interference type line microphone, commonly referred to as a shotgun microphone. It's pretty clear how it got this nickname. It's much longer than a typical end address microphone and resembles the barrel of a shotgun. We have a dynamic range of the microphone. Dynamic range of microphones basically that kind of microphones between the lowest level and the highest level which the microphones can handle. This is not only a function of the microphone alone, but also of the preamplifier used with their microphones. It also describes the ratio between the smallest and largest possible values of the changeable quantity. Frequently encountered in imaging or recorded sound, because dynamic range is another way of stating the maximum signal to noise ratio. Dynamic range is the ratio electronically reproduced audio and video is often produced to fit the original material with a wide dynamic range into a narrow recorded dynamic range that can more easily be stored and reproduced This processing is called the dynamic range comparison. In this, we have the less information than having the self noise and maximum SPL figure individually. How these microphones can be sensitivity. Sensitivity basically refers to a test ability to designate an individual with disease as positive. A highly sensitive test means that there are few false negative results, and thus we will check out the sensitivity is the amount of output for a given input. The input is the sound pressure level at the microphone diaphragm. When measuring microphone sensitivity, a standard 1 kilohertz tone is used with a sound pressure level of 94 dB SPL or 1 Pascal. And active microphones would typically have a sensitivity rating within the range of 8 to 32, and good active microphone sensitivity rating are between also 8 to 32 PA range. Because the high sensitivity microphones create more voltage and so needs less amplification at the mixer or recording mixer device. Now self noise or equivalent noise level. So in this, we will discuss that what is in equivalent noise level. Noise is expressed by the equivalent noise level. Self noise is the signal that microphone produces of itself, even when no sound source or sources is present. Common microphone, basically this is another term for a microphone self noise. Basically this indicates the sound pressure level that will create the same voltage as the self noise from the microphone will produce. The sound level that creates the same output voltage as the microphone does in the absence of the sound, and is particularly important should you wish to record sounds that you are quiet. Self noise is the signal the microphone produces of itself, even when no sound source present again. Now, the proximity effect. Proximity effect in a conductor carrying alerting current. If currents are flowing through one or more other nearby conductors, such as within a closely wound coil of wire, the distribution of current within the first conductor will be constrained to smaller regions. The resulting current crowding is termed the proximity effect. The mutual effect of the current is closely adjacent conductor, producing an apparent increase in resistance, especially with high frequency alerting current. It also having a directional pickup pattern that produces and emphasizes on lower frequencies and caused by the use of ports to create directional polar pickup pattern. Now we have some kinds of the microphones. First is dynamic microphone. Dynamic microphones basically, those are microphones that convert sound into an electrical signal by means of the electromagnetism. They fall into two categories: moving coil and ribbon microphones. A moving coil capsules. At the back of the transparent membrane, you can see the wire coil, which is surrounded by their permanent magnet. When a sound causes the diaphragm to vibrate, the whole assembly works as a miniature electricity generator and a minute electrical current is produced. Basically, it kind of microphone turns sound waves into a voltage with the use of their magnet. They essentially work like speaker but in reverse. In a speaker, electricity vibrates the diaphragm, which creates the sound wave, and on the other hand, use sound waves that vibrates the diaphragm and create electricity. You can see the diagram. This is the space for the sound wave. This is a coil. This is a diaphragm. This is a magnet. And that space would be a wire carrying electrical audio signal. Next is the condenser microphone. Condenser microphone, basically a capacitor microphone, also known as. Condenser mics are mainly used in studios because of their detail and accuracy. Condenser mics are constructed with a lightweight diaphragm which is suspended by a fixed plate. Sound waves causes pressure against the diaphragm which causes it to move. One of these plates is made of very light material and act as the diaphragm, in which we can changing the distance between the two plates and therefore changing the capacitance. Condenser microphone therefore offers superior sound qualities also. Of all microphone types, condensers have the widest frequency response and the best transient response also. In this, there is a sound wave area also. This is the front plate of the diaphragm. This is the back plate of the diaphragm. This is the battery, and area is called the output audio signals. Now there is a ribbon microphone. Ribbon microphone, basically that kind of mic is actually a type of the dynamic microphone. Instead of a dynamic microphone's diaphragm that is attached to a moving coil that vibrates within a magnetic field, ribbon mic feature an extremely thin stripe of metal and suspended in a strong magnetic field. Ribbon mics are the most natural mic that you can use to capture the sound of an instrument, a voice, and even the ambience of a room. Due to their polar pattern, massive low end pickup, and natural high frequency roll off, ribbon rarely hear more like your ears than any other mic out there. The ribbon is electrically connected to the microphone's output, and its vibration within the magnetic field generates the electrical signals. While for some sources you want a microphone to be flattering, ribbon mic are great when you want your recording to sound totally naturally, because ribbon mic will let you record the exact tone you have crafted. Next is the PZM microphone. PZM microphone, basically a pressure zone microphone. A boundary microphone is one or more small omnidirectional or cardiac condenser mic capsule positioned near or flush with a boundary such as a floor, table, or wall. The capsules are typically mounted in a flat plate or housing. They are also offered mounted on walls to record a full room sound. They may also be used to record music in a room along with the room acoustics. By its operation, the boundary microphone is able to prevent the phase interference between the direction and reflected sound, and this results in a more natural sound. Rather than the conventional method of detecting changes in their sounding and surrounding air pressure, that is a sound wave. We have some more microphones types here, that is a carbon microphone. Carbon microphone, basically also known as carbon button microphone. Button microphone or carbon transmitter is a type of microphone, a transducer that converts sound to an electrical audio signal. It consists of two metal plates separated by granules of the carbon. Next, we have a piezoelectrical microphone. Piezoelectric microphone, basically also called the crystal microphone, were used primarily between 1930 and 1960. These microphones use certain crystalline materials which can develop voltage on opposite side when they are bent or deformed. Next, we have a fiber optic. Optic microphone is a device in which the incident sound waves modulate the light guide in optical fibers without the help of electricity. One possible modulation technique is intensity modulation by beam deflection at the moving membrane. Next, we have a laser microphone. Laser microphone, basically a surveillance device that uses a laser beam to detect sound vibration in a distant object. The laser beam is directed into the room through the window, reflects off the object, and returns to a receiver that converts the beam to an audio signals. Next, we have a liquid microphone. Liquid microphone, invented by Alexander Graham Bell and Thomas Watson, were among the first working microphones to be developed, and they were a precursor to be what would later become the condenser microphone. Early liquid microphones used a metal cup filled with water and sulfuric acid. Next, that is MEMS microphone. MEMS microphone is a mic that is produced using electronic chemical system processing technique. MEMS mic are also commonly referred to as microphone chips silicon microphones. These mics are effectively etches into a semiconductive silicon wafer. I'm also telling you that is the full form of MEMS, that is micro electromechanical systems processing techniques. Next, we have a electret. Electret microphone is a type of electrostatic capacitor based microphone which eliminates the need for a polarizing power supply by using a permanently charged material. An electret is a stable dielectric material with a permanently embedded static electric dipole moment. Next and last kind of microphone, that is the crystal microphone. Crystal microphone, a microphone in which sound waves vibrates a piezoelectric crystal that generates a varying voltage. Because a crystalline elements used as a components in various electronic devices. So thank you so much. I hope you clear about the all concept of the microphones. Thank you so much.